right, so this is chapter 11, section 1, spaces, figures, and cross sections. I do want you to put your learning objective, and at the end of this section, you'll be able to recognize polyhedrons and their parts and to visualize cross sections of space figures. So space figures does not mean like a satellite or the Millennium Falcon. It means things that are in 3 dimensions. They take up, instead of a flat surface, they take up space. Just thought I would clarify since it's a part of our learning objective. So if you look at problem number 1, identifying vertices, edges, and faces, we're going to see how many of each this nice little shape has. So we're going to identify each description as a vertex, an edge, or a face. So at the end of this, I want you guys to highlight, because this is definition stuff. So a point where 3 or more edges intersect is a vertex. This is a perfect multiple choice quiz question. I want to make sure you guys nail it. A point where 3 or more edges intersect is a vertex. A polygon is a face. A segment where 2 or more faces intersect is an edge. So make sure on your notes these items, the definition and the word, are highlighted. You guys we're into chapter 11. You know you're going to see this information pop up on a quiz or on a chapter test, so you know to record this. So if we look at our figure here, it's a little cheese wedge, and it wants us to list our vertices. So right now R is a vertice. I would call them, if I was like talking to my kindergarten friends, I would say it was like more corner. So a vertice and a corner are this kind of the same item. So S is on the back top corner. T is in the back bottom corner. U is a front left corner. V is this corner here, and W is the back right corner. List the edges. An edge is a segment. So when I ask you to list an edge on a chapter test, I'm going to ask you to use the right format for listing a line segment. So please make note that it is 2 letters and a line over the top. This is how I want you to list edges. Remember to list the dashed hidden edges. So RS is that top line. BW is the bottom right line. RU is a left line segment. RV is this diagonal line segment. ST is this back line segment, back and to the left. SW is the back diagonal section. TU is the left-hand bottom side. TW is the back hidden bottom line. And UV is the front bottom edge. All right, now think about this. We're going to list faces, and look at the way they're asking you to list a face, because I want you to use the same format to list items on your test. So the first face is quadrilateral RSTW. That's that guy in the back left. Quadrilateral RSWV. That's this top part. Quadrilateral TUVW. TUVW, that's that bottom face. Triangle STW. That one here. And then our other triangle, RUV. Make sure you're listing things correctly because you'll be marked for that. So, now let's take accounting for it. The polyhedron has 6 vertices. It's got 9 edges and 5 faces. Key concept is Euler's formula. We are definitely going to want to highlight Euler's formula. Check out the spelling. E-U-L-E-R apostrophe S. If I encountered it on the street, I would call it Euler, but it is actually pronounced Euler, like Houston Oilers used to be a football team. So go ahead and make sure you have this formula highlighted. The number of faces plus the number of vertices is equal to the number of edges plus 2. All right, so if we were to, use Euler's formula to find the number of faces for a polyhedron with 30 edges, 20 vertices. So we're going to start with our formula F plus V equals E plus 2. How many V's we got? How many vertices? 20. How many edges we got? 30. 30 plus 2 is 32. Subtract 20 from both sides. 32 minus 20 is 12. So a polygon with 30 edges and 20 vertices has 12 faces. All right, so use the solid at the right. So this nice little trapezoid prism. How can you verify Euler's formula? F plus V equals E plus 2 for the solid. So we count the number of vertices. So that's corners. 1, 2, 3, 4 corners on the bottom. There is that amount. 1, 2, 3, 4 corners on the top. So for a total of 8 vertices. Count the number of faces. I think of it as front, back, top, bottom, left, right. So I have a front and a back, that's 2. I have a left and a right, that's 2. I have a top and a bottom. That's 2 more, for a total of 6. Okay, so let me do it. That's the way I think of it. I will do it this way because we will need to know about lateral shenanigans. There are 2 bases, so there is a top, a front and a back. There are 4 lateral faces. That means left, right. Bases must be top and bottom. Bases is top and bottom, left, right, front, and back. So I want to just focus here real quick on the lateral faces. That is this guy here, this guy here, the guy in the back, and the guy on the left. So as you go spin around your shape, lateral is everything you see on the sides. We're going to be using that in formulas next section, so might as well explain it correctly now. The number of edges. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 solid edges. I look at my dashed lines, I see 3 dashed lines, which makes a total of 12 edges. All right, verify Euler's. Faces is 6. Vertices is 8. Edges is 12, and we're going to add 2 to that. 6 plus 8 is 14. 12 plus 2 is 14. Verifies. So for the solid at the right, what is the cross section formed by the horizontal plane? So I'm going to take my knife. It's my ninja knife. It's like a saber. And I'm going to chop it horizontally. So once I do that, my slice is going to look right on top of that and give me a circle. Okay. So the horizontal plane is parallel to the bottom of the solid, because the side of the solid is not. A view from the top helps us see the cross section, and the cross section is a circle because we're looking down from the top. Oh. Oh. It is a circle. All right. So now we get to draw a cross section on this nice little guy, this nice little rectangular prism here. So we're going to draw a cross section formed by the horizontal plane. So we're going to take our knife and cut it horizontally, and then tell what shape the cross section is. A horizontal plane is parallel to which faces of the cube? Oh, not the front and back. Not the left and right. But right, the top and bottom. It is parallel to the top and bottom. So we're going to circle the diagram that shows the intersection of the horizontal plane and the left and right faces of the cube. Oh yeah, that's the first one. So it's these guys. So my horizontal plane is going to chop it. So you use that as your starting place. And then you take your line here so that you can see if I cut this horizontally, we're going to have half of our cube on top and half of our cube on the bottom. And the cross section is going to be a square. It's a square.